we are going to be looking at the other types of bond that we have apart from those ones that have been previously discussed. And the one we are going to be talking about extensively is hydrogen bond. Now, we started explaining the concept behind hydrogen bond in the last class, but we are not able to look at how it actually happens in atoms. Now, for hydrogen bond, we have said hydrogen bond occurs when hydrogen is bonded with highly electronegative elements. Highly electronegative elements like oxygen, fluorine, and nitrogen. Now, hydrogen bond is, as I've said in the last time, that is an intermolecular force of attraction. It is inter because it happens between two molecules, while the other bonds like covalent bond, coordinate covalent bond, electrovalence bond, those ones are intra because they happen within the molecule, not that they are joining two molecules together. Those ones are joining two atoms together, but hydrogen bond is a kind of bond that joins two molecules together. Now let's see how hydrogen bonds, how it occurs. Now what's going to happen is that let's assume that we want to look at the hydrogen bond between hydrogen and oxygen to form water. Now how is this going to happen? Now this is our hydrogen atom, which has only one electron in the first shell, and we have our oxygen atom, which has 6 electrons. That's 2, 6. So we have 1, 2, 3, 4, 5, 6. So it needs 2 electrons. So that means that it has to react with it's going to react with 2 hydrogen atoms. So we are going to have another hydrogen atom. Then they are going to share their electrons with our oxygen. So we are going to have something like this. This is the oxygen. We have 2. Then it has 6 electrons. So 1, 2, 3, 4. Those are 2 of them. There are 4. Those are 4 of them. Remaining 2. So 5 and 6. Now hydrogen will come and share its electron, share 1 electron with this, share 1 electron with the other one. Now if you notice this, if you decide to consider the charges of these atoms, now we know that for oxygen at the center, oxygen has 8 protons because the atomic number is 8. So it has 8 protons. It has 8 positive charges, while hydrogen has only 1 proton, so 1 positive charge inside it. Now I'm not saying that hydrogen here is having a positive charge. No, I'm just saying that inside the nucleus of hydrogen atom there is 1 positive charge. Then there is 1 positive charge inside the nucleus of this hydrogen atom also. Now what's going to be happening is that since these are electrons which are negatively charged, and inside here we have 1 proton which is positively charged, that proton will be attracting these electrons because they are of opposite charges. You know that in physics, like charges repel, unlike charges attract. So that means that a positive charge will attract a negative charge. So the same thing here, the positive charge at the center of the other hydrogen will also attract these electrons. But if you look at it, in the center of oxygen there are 8 positive charges, so which means that those 8 positive charges will also be attracting these electrons towards oxygen, and they will be attracting these electrons towards oxygen. Now what this is going to result to is that these electrons are going to be closer to oxygen than to hydrogen. Why? Because oxygen has more positive charged particles that are pulling those electrons towards it. It has more protons pulling the electrons towards it. So which means overall those electrons are going to be closer to oxygen than to hydrogen. Then we might be able to draw the structure this way just to exaggerate the diagram. You can draw something of this nature. Then for the oxygen, you draw something of this nature for oxygen. I'm just trying to exaggerate the diagram. Then for the other hydrogen, now we have two electrons, then we have 2 and 2. Now if you look very closely at this, you see that these electrons are closer to oxygen than they are to the two hydrogen atoms, which means that these hydrogen atoms are almost losing those electrons. Even though they did not lose them, they are almost losing them because oxygen is pulling them towards itself. Now what this is going to result to is that since hydrogen is almost losing the electrons, that means hydrogen is going to have a partial positive charge. It is going to have a partial positive charge because we know that if it loses the electron completely, then that's when we write it as H plus. That means that it becomes positively charged. But since it is almost losing the electron, it's going to have a partial positive charge. This is how we write partial positive charge, especially when you are dealing with bonding. So it's almost losing those electrons. This hydrogen too, we have a partial positive charge. Now this oxygen, we have a partial negative charge. It's going to have a partial negative charge, which means that it is almost gaining the electrons. So now, which means that this molecule as a whole is going to become polar. Now what I mean by polarity means that it has charges, even though the charges are partial, but it is still what? It is still polar. So which means that the hydrogen part of this molecule is going to be what? Is going to be partially positive, while the oxygen part of this molecule is going to be what? Partially negative. Now let me remove this and give more description of this. Now which means that since we're having H2O, that means that we are going to have H2O, then we are going to put a partial positive charge on the hydrogen, a partial negative charge on the oxygen. Now what this means is that if we have another water molecule, which is also H2O, this will also have a partial positive charge, a partial negative charge. What do you think is going to happen? What is going to happen is that this partial negative charge that we have here will be attracting the partial positive charge that we have here, and this partial positive charge that we have here will be attracting the partial negative charge that we have here, which means that so there's going to be a kind of intermolecular force of attraction between this water molecule and this water molecule. Now this one is not within the molecule itself, this one is what? Outside of the molecule, between these two molecules, so they feel attracted towards themselves. So which means that if you have a water molecule, let's say we have a water molecule this way, let's say we have H2O, and it's trying to come close to this one, it won't come close in this manner because of what? Because this one is having a partial negative charge, so it will repel this one. So the only way it can come close to it is for the hydrogen part of it to come first, so that the negative charge here will attract the positive charge here. So to denote that bond, we are going to denote it by dotted lines. So there's going to be a kind of force of attraction between this oxygen and this hydrogen. Between this oxygen and this hydrogen, there will be a force of attraction. Between this hydrogen and another oxygen, there will also be a force of attraction. So that force of attraction that is between them due to the partial charges that they possess is what you call the hydrogen bond. So it doesn't happen in water alone. It also happens in other compounds that contain hydrogen and oxygen, hydrogen and nitrogen, hydrogen and fluorine. So those are what? Those are the examples of the where we can find the hydrogen bond. So, and that is the explanation behind it. Now, don't forget that hydrogen bond is also weak. It is also a weak bond, but it is very important. It is very important. So I think we are done with that. Now we can move to the next aspect of chemistry that we are going to be looking at today, and that is what? The kinetic theory of matter. The kinetic theory of matter. Now also we are going to be looking at, under the kinetic theory of matter, we are going to be looking at the gas laws. Now before we look at the gas laws, you need to know what the kinetic theory of matter is all about in chemistry, and also some things that we actually need to know before we move into the gas laws. Now we have known before that they have told us in physics that matter is composed of particles. And those particles can come in form of atoms. It's either they come in form of atoms, or they come in form of molecules, or they come in form of ions. So these are what? These are the particles that make up matter. So you can have matter that is made up of atoms, you can have matter that is made up of molecules, and you can have matter that is made up of ions. Now, what the kinetic theory of matter is now trying to tell us, now is very similar to the kinetic molecular theory that we did in physics. Now what this one is also trying to tell us is that all these particles are in continuous motion. The particles are in continuous motion. So all these particles are in continuous motion. So we can say, so they possess kinetic energy. They possess kinetic energy because we said they are moving, and you can't have something moving without having kinetic energy. Now they will now tell us, they want to tell us another thing that is very similar to what we know from physics also. And by the time I mention it, you are going to notice that it is similar if you can recall what we did in our physics. Now, an increase in temperature causes an increase in the average kinetic energy. The average kinetic energy of these molecules, of these particles. So that's another thing that we must know. The kinetic theory is telling us that what? Matter is composed of particles, and these particles are in what? Continuous motion. They are in continuous motion. That means that they are always moving. So that means that we can say that what? They possess kinetic energy. Then it's now trying to also tell us the relationship between the temperature of these particles and their what? And their average kinetic energy. It's telling us that when we increase the temperature, the average kinetic energy of these particles will also increase. So which means that what? They will move faster. They become more energetic and move faster. That is what the kinetic theory of matter is telling us in chemistry. It is very short, so we need to know them. Now another thing we need to know are the states of matter that we have in chemistry. States of matter is very exactly the same as those that we discussed in physics. So we have the solid state, we have the liquid state, and the gaseous state. So these are the three states of matter that we have. Now let's talk a little bit about each one of them. Now what should we know about the solid state of matter? Now the first thing we should know is that what? They are tightly packed. Solid particles are tightly packed. So that means that if you want to represent solid particles in diagram, you draw something like this. You won't leave space. You won't leave spaces between the atoms to show us that what they are tightly packed. Now, apart from being tightly packed, they are held together. They are held together by high coercive forces. They are held together by what? By very high forces of coercion. Now, what do we mean by a cohesive force? Now, a cohesive force is a force that holds two things that are the same together. That's what we call a cohesive force, which means that if you have one water molecule, you have another water molecule, the force that holds them together is going to be a cohesive force, which means that hydrogen bond is an example of a cohesive force. Why? Because it holds two water molecules together. So it is an example of a cohesive force. But if the two things that are being held together are different, then it's going to be called an adhesive force. It's going to be called adhesive force and not cohesive force. So they are telling us that for solids, they have very high forces of coercion. Now, those forces can be of various types, just like those ones that we just finished discussing in our chemical combination. So they can be electrovalent bond, they can be covalent bond, they can be metallic bond, and they can even be van der Waals forces. So, and those forces are going to be the ones that will determine the strength of that particular solid. They are the ones that will determine the strength of the solid, which means that if it is a covalent bond, if it is an electrovalent bond, then the solid is going to be very strong, because electrovalent bonds are very strong. But if it's a covalent bond, then it's not going to be a very strong solid. Or if it's even a van der Waals bond, then it's not going to be very strong. Now, so another thing that we need to know is that the molecules of solids are not free to move, or the particles of solids are not free to move, but so they vibrate. They vibrate about a main position. So this is another one that we should know. And we have discussed all of this in physics, that solid molecules are not free to move. They are not free to move. So they do what? They can only vibrate about their positions. Now, another thing is that these molecules can also rotate. That's another thing that we need to know. It's also possible for solid molecules to rotate. That means that they can turn. But it's not possible for them to leave where they are. They can't leave that particular position and move to another position. It's not possible. They can vibrate, they can rotate. That means they can turn, they can go to and fro, but they cannot leave that position. It's not possible for them to now leave and go to another position. It is not possible. So, because of all these that we have mentioned, solids have a fixed shape and are difficult to compress. So solids are difficult to compress. They are difficult to compress because they are tightly packed. They have a fixed shape because their molecules cannot leave that particular position that they are. So compression means that you want them to occupy a smaller space. So you have to keep them tight together. But they are already tight together. So that means that they are already held in tight position. So it's not possible for you to say you want to compress them further. So solids are very difficult to compress. So let's look at liquids. What are those things that we need to know about liquids? Now, for liquid molecules, for solids, we say they are tightly packed. Now, for liquids, they are further apart than solids. So that means that the molecules of liquids are not tightly packed. They are not tightly packed. So they are further apart. That means they have more spaces between the molecules. Another thing that we need to know is that they have more kinetic energy. They have more kinetic energy than solid molecules. So because of having this more kinetic energy, they are no longer held in fixed positions. No longer held in fixed positions. So this is because of their high kinetic energy and also their low cohesive forces. Because of their low cohesive forces. So that means that the force that is holding them together is smaller compared to the energy that they have. But for solids, the force that is holding them together is very high compared to the kinetic energy that they have. So it's not that solids too don't have kinetic energy, they have, but the kind of resistance that they are facing is higher than what liquid particles are facing. So liquids have higher kinetic energy, and also as a result of their low cohesive force, it is very easy for them to do what? To move about. So they are not held in fixed position. So another thing that we need to know about liquid molecules is that just because they are moving about does not mean that they no longer have cohesive forces. They are still under the influence of forces. The cohesive forces are still there. Let's say they have low cohesive forces. So the cohesive forces are still there, but they are smaller as compared to that one that we have in solids. So that's another thing that we need to know. Now, another thing that we need to know is that for liquids, they possess a fixed volume. They possess fixed volume. They possess fixed volume, just like solids. Solids also have a fixed volume, but they do not possess a fixed shape. They do not possess a fixed shape. So they possess fixed volume, but they do not possess fixed shapes. So liquids assume the shape of their containers. Now for liquids also, they are also difficult to compress. They are also difficult to compress. So liquids are also difficult to compress, just like solids. Although their own might be easier than solids, but they are also difficult to compress. Now the last one we need to talk about are the gases. Now what do we need to know about gases? Now for gases, they have higher kinetic energy. They have higher kinetic energy than even liquids. Now for them, their own cohesive forces, the cohesive forces are negligible. The cohesive forces in liquids are negligible, so the particles are free to move about. So because of those negligible forces, that means that they are very small. They don't serve much purpose. So that is why liquid molecule, the molecules of gases are very free to move about at very high speed. They move about at very high speed. So because of this, a gas has no definite shape. They have no fixed shape. At the same time, a gas has no fixed volume. So gases have no fixed shape. They also do not have a fixed volume. Now, because these guys are very free to move about, let's say you have gas molecules, look at how far apart they are. They are just moving at anyhow they are. So because of this very large space that they have, they are highly compressible, because they have very large space in between them. So it's very easy for us to compress them. What I mean by compress them is that at the end you're going to have something like this. We want to bring them closer together. So look at that, we have decreased the space between them. So this is what you call compression. But for solids, look at how solid molecules are. What do you want to compress in this particular substance? This one can't be compressible because there is no space for you to compress them. So for gases, they are highly compressible. So those are the things that we need to know about the states of matter that we have. Now let's move to change of state. Change of state. Now change of state means that it is possible that you have a substance that is going to change from one state to another. So that means that a substance can be solid, then it changes to liquid. A substance can be liquid, then it changes to gas. A substance can be gas, changes back to solid, or changes back to liquid. So now when we want to change the state of a substance, we heat the substance. Is either we heat it or we cool it. We cool the substance. Now the heating means that we are increasing the temperature, while the cooling means we are decreasing the temperature. So these things are very important for us to change the state of a substance. Now the reason these guys are important is because the state of matter is very dependent on the kinetic energy of the particles that it contains. It's very dependent on the kinetic energy of the particles. So and we know that liquids have high kinetic energy. So that means that when you want to change from solid to liquid, that means that you have to look for a way to increase the kinetic energy. And how can you increase the kinetic energy? They have told us from the kinetic theory that we increase the temperature. That's how we can increase the kinetic energy. And when you want to increase the temperature, what do? You heat. But when you want to decrease the temperature, what do? You cool that particular substance. So let's start with the first one, which is melting. Now, how does melting occur? How does melting occur? So what happens is that when you are melting, you can only melt a solid. So you have solid particles and you want to melt them. That means that you want to change them to liquid particles. So that means that you are going to do what? You are going to have to find a way to increase their kinetic energy by giving them heat, by supplying heat to them. Now what's going to happen to them? They are going to start vibrating because they cannot move. They are molecules of a solid. They are particles of a solid. So it's not possible for them to move. So they now start vibrating as they are undergoing an increase in kinetic energy, as they are undergoing an increase in temperature. They start vibrating violently until they are able to do what? They are able to break that bond that is keeping them in place. Now when you start heating them, their temperature will start rising. The temperature will start increasing. Now the temperature will now increase to a point where these molecules will be able to break the coercive force and be free to move about and become molecules of liquid. Now at that point, the temperature at that point is what you call the melting point. The melting point. The temperature at that particular point where they were able to break that bond is what you call what? The melting point. Now for water, the melting point of water is what? 0 degrees Celsius. So that means that, for ice, the melting point of ice is 0 degrees Celsius, which means that when ice gets to 0 degrees Celsius, it will be able to break the coercive forces and go beyond the boundary of being a solid, and it is going to turn to liquid particles. So this is where we are going to continue in the next class.